Hello, good morning students. Today we are going to discuss the Taylor series expansion of sin x and cos x. Theory is, if f of x is a continuous function defined on a domain containing a point A. So this function is having a particular value at the point A. And if the function is infinitely differentiable at A, the functional value at a point x in the neighborhood of A can be obtained using Taylor series expansion. So that means if we know the value of a function at a point, suppose we have a function, f of x, and we know the value of the function at some point x is equal to a, and we can find, and if the function is differentiable, infinitely differentiable, we can find the value of the function at a neighboring point, at a nearby point, say new point x is equal to a plus h, using this Taylor series expansion. Now suppose we the function at the point a is f of a. We want to find the value of the function at a neighboring point x. That is, we want to find f of x. What we know? We know the value of the function at the point a, and we want to find the value of the function at a nearby point x. It's a general case. And suppose x is very close to a, the neighboring point. So f of x is equal to the value of the function at the point a plus x minus a, the difference between the values of x and a, x minus a by 1 factorial into the derivative of the function at the point a, f1 of a. f1 of a means the derivative, first derivative of the function at the point a, plus x minus a all squared by 2 factorial into f2 of a. f2 of a means the second derivative of the function at the point a. x minus a all cubed by 3 factorial into f3 of a plus etc. x minus a all raised to n divided by n factorial into fn of a plus etc. So this is actually the Taylor series expansion. Here f1 of a means dou f by dou x at x is equal to a. f2 f a means dou squared f by dou x squared at x is equal to a, etc. fn of a means dou f by dou xn, dou n of x by dou xn at x is equal to a. Nth derivative of the function at the point x is equal to a. Now, so this form may not be familiar to you. If the neighboring point x is such that x is equal to a plus h, a plus h. So what will be the form of this equation? The neighboring point is a plus h minus a will become h. A plus h minus a all squared becomes h squared. A plus h minus a all cube means h cube. Okay. If the neighboring point is x such that x is equal to a plus h, then we can write f of a plus h is equal to f of a plus h minus a, that is x minus a becomes a plus h minus a, that is h by 1 factorial into f1 of a plus h squared by 2 factorial into f2 of a plus h cubed by 3 factorial into f3 of a plus etc. h raised to n by n factorial into fn of a plus etc. So this is the form of the Taylor series you might have studied. Now suppose we have a function, we want to find the Taylor series expansion of sin x. If the function is sin x, if the function is sin x, f of x is equal to sin x, we can write sin x is equal to sin 0 plus x. So this way we can write sin x. Sin 0 plus x is simply sin x. So this is of the form f of a plus h. But our function is sin x. So sin x can be written as equal to f of a plus h is equal to f of a plus h by 1 factorial into f1 of a plus etc. plus h squared by 2 factorial into f2 of a plus etc. Same way we can write sin x is equal to f of a simply means the value of the function at the point a. See, the point a here means a is equal to 0. So value of the function at the point 0, that is sin 0, plus what is this is 0 plus h. Instead of a plus h, it is 0 plus h. So 0 plus x minus 0, that is x. Okay, that is 0 plus x minus 0. The value of the function a plus h minus a. Instead of a plus h, we have 0 plus x. A is equal to 0. So a plus h minus x simply means a plus h minus a simply means x. Here sin x is equal to sin 0 plus, this is, what is h here? Instead of h you have to put x. X by 1 factorial into dou by dou x of sin x at x is equal to 0 plus h squared by 2 factorial. Instead of h squared by 2 factorial, actually there is a mistake. This is x squared by 2 factorial. X squared by 2 factorial into dou squared by dou x squared into sin x at x is equal to 0 plus what comes in the place of h here? It is x. This is again x cube by 3 factorial into dou cube by dou x cube into sin x at x is equal to 0 plus etc. Now we have to find what is the value of dou by dou x of sin x at x is equal to 0. Derivative of sin x is what? Cos x. At x is equal to 0 means cos 0 is equal to 1. So this quantity becomes 1. So sin 0 plus dou by dou x of sin x becomes 1. Sin x is equal to sin 0. We know sin 0 is equal to 0. So this is, first term is 0. Sin x sin 0 is 0. Okay. Then second term is plus x by 1 factorial into dou by dou x of sin x at x is equal to 0. This quantity becomes equal to 1. So this is x by 1 factorial, that is simply x. Now what is the second term? Plus x squared by 2 factorial. X squared by 2 factorial into dou squared by dou x squared of sin x. Dou by dou x of sin x is cos x. So you take the derivative once again, you will get dou squared sin x by dou x squared, that is dou by dou x of cos x. Dou by dou x of cos x is equal to sin x, that is 0. It is 0. So derivative of sin x is equal to dou squared sin x by, okay, you will get it as this term becomes 0. X squared by 2 factorial into 0, that becomes 0. Then plus x cube by 3 factorial into dou cube by dou x cube of sin x. So dou squared sin x by dou x squared, that is equal to 0. You take the derivative once again, that is dou cube by dou x cube of sin x. Dou squared by dou x squared of sin x is equal to minus sin x. You take the derivative of this once again, you will get dou cube by dou x cube of sin x. So that is derivative of sin x is equal to cos x. But there is already a minus sign, so minus cos x will come here. So this becomes cos x at x is equal to 0, cos x is equal to 1. So there is a minus sign here, so minus 1 here comes here. So this term becomes minus of x cube by 3 factorial. X cube by 3 factorial. Then if you continue like this, you can see sin x is equal to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial plus x raised to 7 by 7 factorial plus x raised to 9 by 9 factorial minus x raised to 11 by 11 factorial, etc. So you can see that next step, dou squared sin x by dou x raised to 4. Cos x ന്റെ ഡെറിവേറ്റീവ് sin x ആണ്. sin x ന്റെ 0 വരുന്നു. x is equal to 0 യിൽ sin this term will be 0. x raised to 4 by 4 factorial term will not come in this series. Next line എടുക്കുന്നു dou squared 5 by dou x raised to 5 of sin x at x is equal to 0. cos x എന്ന് കിട്ടും. It will be plus 1. So fifth term will be positive. So even പവേഴ്സ് വരുന്ന ടേം ഓഡ് പവേഴ്സ് വരുന്ന ടേമുകളാണ് എക്സിസ്റ്റ് ചെയ്യുക. അതുപോലെ തന്നെ ആൾട്ടർനേറ്റീവ് ടേമുകൾ പോസിറ്റീവ് നെഗറ്റീവുമായിട്ട് നിങ്ങൾക്ക് ഇങ്ങനെ കിട്ടും. സോ ദിസ് ഈസ് ദ ടൈലർ സീരീസ് എക്സ്പാൻഷൻ ഓഫ് sin x. sin x is equal to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial plus minus x raised to 7 by 7 factorial plus etc. Similarly, you can write cos x is equal to cos 0 plus x. That is cos 0 plus x by 1 factorial into dou by dou x of cos x at x is equal to 0 plus, again I have to put not x squared, that is x squared by 2 factorial into dou squared by dou x squared of cos x at x is equal to 0 plus etc. Plus x cube by 3 factorial into dou cube by dou x cube into cos x plus etc. plus x raised to n. കാരണം ഇവിടെ എച്ചിൻ്റെ സ്ഥാനത്ത് എന്താ വരുന്നത്? എക്സ് ആണ് വരുന്നത്. സോ വി ഹാവ് ടു റീപ്ലേസ് എച്ച് ബൈ എക്സ്. സോ വി നോ cos 0, ഫസ്റ്റ് ടേം cos 0 is equal to 1. So first term is 1. Now dou by dou x of cos x, ഫസ്റ്റ് ടേം വരുന്ന നോക്കൂ. cos x ന്റെ ഡെറിവേറ്റീവ് sin x ആണ്. at x is equal to 0, it is sin x is equal to 0. So first term, this term will be 0. x ന്റെ ടൈം അവിടെ വരില്ല. നെക്സ്റ്റ് ടൈം dou squared by dou x squared of cos x, sin x ന്റെ ഡെറിവേറ്റീവ് എടുക്കുന്നു, you will get cos x. But already there is a minus sign, so minus cos x, so we will get minus 1. So minus x squared by 2 factorial will come here. Next term dou cube by dou x cube of cos x, sin ടൈം വരിക, ഡെറിവേറ്റീവ് ഓഫ് cos ന്റെ ടൈം വരുമ്പോൾ sin വരും, so that will be 0. x cube ന്റെ ടൈം ഇവിടെ വരില്ല. Then fourth derivative, dou raised to 4 of dou x raised to 4 of cos x. So sin x ന്റെ ഡെറിവേറ്റീവ് ആണ് ഇവിടെ വരിക. This is cos x, so that is plus 1. So x raised to 4 by 4 factorial. Next term x raised to 5 വരുന്ന ടേം, sin ന്റെ ടൈം വരുന്നു, that will be 0. Then 6 വരുന്ന ടേം, sin ന്റെ ഡെറിവേറ്റീവ് ആണ് വരിക, that is cos വരും. But there is a minus sign already here, so minus cos x varum, so you will get minus 1. So minus x raised to 6 by 6 factorial. So this will continue. So cos x is equal to 1 minus x squared by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus x raised to 8 by 8 factorial, etc. So sin function and cos function Taylor series expansion is this. So basically our expression is this, the Taylor series expansion എന്ന് പറയുന്നത് ഇതാണ്. ഇതിൻ്റെ അകത്തു നിന്നാണ് നമ്മൾ ഈ കോസ് ഫംഗ്ഷൻ്റെയും സൈൻ ഫംഗ്ഷൻ്റെയും ടൈലർ സീരീസ് എക്സ്പാൻഷനിലേക്ക് എത്തിച്ചേരുന്നത്. So f of a plus h is equal to f of a plus h by 1 factorial into f1 of a plus h squared by 2 factorial into f2 of a plus h cube by 3 factorial into f3 of a plus etc. ഇവിടെ നമ്മൾ സൈൻ ഫംഗ്ഷൻ എടുക്കുമ്പോൾ sin x എന്ന് എടുക്കുമ്പോൾ sin 0 plus x എന്ന് എടുക്കുന്നു. സോ എയുടെ സ്ഥാനത്ത് എന്ത് വരുന്നു? 0 വരുന്നു. എച്ചിൻ്റെ സ്ഥാനത്ത് x വരുന്നു. സോ we can expand it and we can find the series of sin and cos. The sin x in the series, sin x is equal to x minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial plus etc. Similarly, the cos series is cos 1 minus x squared by 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial plus etc. Okay, thank you.